यार सर्दियों के साथ बहुत सारी चीजें चली जाती हैं,
जैसे
हमारी टाइम पास वाली मूंगफली
और गर्मा गर्म अदरक वाली कड़क चाय।
और खाने के बाद ये गजक, सब चला जाएगा यार सर्दियों के साथ।
ऐसा नहीं है भाई, सर्दियां जा रही हैं लेकिन सुपर कोचिंग पर डिस्काउंट भी तो आ रहा है। सुपर कोचिंग लेकर आ रहा है विंटर फेयरवेल सेल, जहां पर सभी कोर्सेज पर मिल रहा है 90% तक का डिस्काउंट।
Hi, good evening everyone. This is Shefali Singla, and in this session we are going to discuss few more previous year questions asked on the basis of computer organization and architecture. तो कल हम लोगों ने यूनिट 2 के कंप्यूटर आर्किटेक्चर से क्वेश्चंस डिस्कस करने शुरू किए थे. So we will be focusing on the questions based on the memory access. We will be discussing the questions on the basis of disk. तो हर क्वेश्चन के लिए हमारे पास 2 से 3 मिनट का टाइम है, बट आई विल गिव यू 30 सेकेंड्स टू गो थ्रू द क्वेश्चन को रीड कीजिए, ट्राई टू अटेम्प्ट इट, और अगर कहीं पे कोई डाउट है फील फ्री टू राइट इन द चैट सेक्शन. टेस्ट बुक पेड भी अगर आप क्रैश कोर्स कुछ स्टार्ट किए तो आप बता दीजिए. डेफिनेटली अरजीत. सो व्हाट यू कैन डू इज, अभी के लिए अगर आप पेड बैच भी ज्वाइन करना चाहते हो तो यू कैन ज्वाइन इट नाउ, बिकॉज अभी जैसा आप स्क्रीन के ऊपर देख पा रहे हो, करेंटली द सेल इज गोइंग ऑन. तो क्रैश कोर्स इज लाइक कि अगर आप करते हो तो उसमें फटाफट से सारी चीजें कवर होंगी, तो बेटर है कि अप्रैल तक तो हम वैसे ही डिटेल सिलेबस खत्म कर रहे हैं. So we are having the morning session and the evening for paper 2 and afternoon में paper 1 का सेशन होता है. तो अप्रैल तक खत्म हो जाएगा. क्रैश कोर्स में भी 2.5 महीने से कम में कहाँ ही सिलेबस खत्म हो पाएगा, बिकॉज सिलेबस इज टू मच फॉर यूजीसी नेट, राइट? So why you want to get the crash course? Very good evening Nitika, good evening Shubham. So we'll be covering like 7 to 8 questions. We'll try to discuss 10 questions in 30 minutes. देखते हैं कितने हो पाते हैं. Okay, so you want to focus on previous year questions. Definitely, I'll let you know. So first of all, this is the first question for today's session. So it is saying that for a magnetic disk with concentric circular tracks, the seek latency is not linearly proportional to the seek distance. तो seek latency directly proportional नहीं है with the seek distance. Why is it so? What is the reason behind that? कल मैंने थोड़ा सा आपको स्ट्रक्चर बना के बताया था, डिस्क का स्ट्रक्चर, वेयर द डेटा इज स्टोर्ड इन ऑन द डिस्क सर्फेसेस. डिस्क में कई बार दोनों साइड रिटन होती हैं, एंड द ईच सर्फेस इज डिवाइडेड इनटू द ट्रैक्स, फर्दर इट इज डिवाइडेड इनटू द सेक्टर्स, एंड फाइनली द डेटा इज स्टोर्ड इन द फॉर्म ऑफ दिस इन द सेक्टर्स. This YouTube class is daily or not? This is daily except for Monday and Tuesday. जैसे पेड बैच में मैंने स्केड्यूल बताया हुआ है. सो इवनिंग्स आर ऑफ फॉर मंडे एंड ट्यूसडे, मॉर्निंग इज ऑफ फॉर थर्सडे. वेरी गुड इवनिंग अरुण. सो व्हाट इज द आंसर? हमने ये बोला कि सीक लेटेंसी लीनियरली प्रोपोर्शनल नहीं है सीक डिस्टेंस से. सो व्हाट इज द रीजन बिहाइंड दैट? फर्स्ट ऑफ ऑल, व्हाट इज द सीक लेटेंसी? सीक लेटेंसी क्या होती है? See, when the write head wants to read some data from the particular sector, तो सबसे पहले आपको ट्रैक लोकेट करना पड़ता है, कौन से ट्रैक के कौन से सेक्टर से डेटा रीड करने. दैट मीन्स देयर विल बी अ मूवमेंट इन द रीड राइट हेडर, so that movement is known as the seek latency. Now, it is not directly proportional to the seek distance. The reason is जब आप का read write header move करता है, then we need to check that what is its starting location and where it is gonna stop, right? Moreover, when we are accessing the data, sometimes the data is accessed from the random sectors or the sequential sectors. मान लीजिए मुझे 5 सेक्टर का डेटा रीड करना है, हो सकता है कि वो 5 सेक्टर्स कंटिग्यूस हों, सिक्वेंशियल एक्सेस हो. ये भी हो सकता है कि सेक्टर 1 ट्रैक 100 पे आ रहा है, सेक्टर 2 ट्रैक 55 का आ रहा है, सेक्टर 3 किसी और ट्रैक आ रहा है. सो दैट इज द रैंडम एक्सेस. सो डेफिनेटली देयर विल बी the difference. So every time you need to move the header, so definitely the seek latency will be changing. टेक्स्ट बुक ऐप पर भी आप ही क्लास ले रही हैं क्या? डेफिनेटली यस. So what should be the answer? Is it dependent on non-uniform distribution of request? No. Is it dependent on arm starting? मतलब कहाँ से arm start हो रही है और कहाँ पे stop हो रही है? Yes. Higher capacity of tracks on the periphery of the plate. इसका capacity से कोई लेना देना ही नहीं है. So 3 cannot be the answer. Use of unfair arm scheduling policies. It has nothing to do with the unfair policies. Is this clear? So the correct answer for this question is it's option 2. Next one. Now this is based on cache memory. So in a cache memory, if the address has 9 bits in the tag field, यानी कि tag bits आपको 9 दी हुई है. So here we are given with the tag bits. So number of tag bits are 9 and the index field bits are given as 12. So here it is using 9 bits and here it is using 12 bits. Index means you are accessing the particular word. So the size of main memory and the cache memory would be respectively, what will be the size of the main memory? See, if we have the bits divided into the tag bits and the index bits, so here we have tag bits and here we have index bits. Tag bits are 9. There are 9 bits in the tag and there are 12 bits in the index. Now, what are these tag bits? अगर आपको मेन मेमोरी का साइज रिप्रेजेंट चाहिए तो हाउ विल यू कैलकुलेट द मेन मेमोरी साइज? अब यहाँ पे आपको बिट्स से कहाँ पे जाना है? टू द साइज. दैट मीन्स वी विल बी टेकिंग दैट इन द फॉर्म ऑफ 2 रेज टू पावर. 2 रेज टू पावर में क्यों लेंगे? क्योंकि जो बिट होती है इसकी वैल्यू 0 या 1 हो सकती है. अगर आपके पास 3 बिट्स हैं, if there are 3 bits, so for all the bits there are 2 options available. First bit can be 0 or 1, second bit can be 0 or 1, third bit can be 0 or 1. This means that 2 raised to power 3 combinations are possible. Similarly, if we have 9 bits, that means 2 raised to power 9 combinations are possible. So what are these 2 raised to power 9 combinations representing? अगर आपको memory represent करनी है तो memory bits, total memory bits or memory capacity is divided into the tag bits or the index bits. So total number of bits here are, total bits are equal to the tag bits plus index bits. Very good. So tag bits plus index bits, that is nothing but 9 plus 12. Total bits हो गई 12. Sorry, 9 plus 12 is 21 bits. So with 21 bits, 2 raised to power 21 combinations are possible. So we can say that main memory will be 2 raised to power 21. 2 raised to power 21, if you look at the options, these are the commas. If you look at the options, this is given in the form of k. K is nothing but that is 2 raised to power 10. We know that 1k is equal to 2 raised to power 10. So I can expand this as 2 raised to power 11 into 2 raised to power 10. मैंने इस फॉर्म में क्यों डिफाइन किया? अदरवाइज आई कुड हैव रिटन दिस एज 2 mega. So 2 into 2 raised to power 20. But since all the options are given in the k, so I'm writing it in this format. So 2 raised to power 11 is nothing but that is 2048 and 2 raised to power 10 is k. On the basis of the first value, you can eliminate the options. 2k, incorrect. 1024k, 4k. So already we have got the answer, but still let's calculate the memory size. Undoubtedly, the answer for this question is option 4. What would be the cache memory? Cache memory कितनी होगी? Cache memory को represent करने के लिए हमारे पास क्या आ रही है? Index bits. Index bits are 12 bits, so we can say that cache memory is 2 raised to power 12. 2 raised to power 12. Again, we want this in terms of kilo. So it can be written as 2 raised to power 2 into 2 raised to power 10. That is nothing but 4K. So cache memory would be 2 raised to 4K. Make sense? Definitely यहाँ पे कैशे के लिए सिर्फ इंडेक्स बिट्स गिवन है. So there are no offset bits. तो हम सिर्फ इंडेक्स बिट्स कंसिडर करेंगे. अगर ऑफसेट बिट्स गिवन होती तो डेफिनेटली we could have taken here the index offset bits also. Offset is not given, so that's why it will be 0. Anyhow, that is not going to impact your answer. So correct option for this question is it's option 4. Let's move on to the next question. Here, this is based on the average access time required to access a page. Just give it a try. A very simple formula will be applicable here. Average time required to access a page is required. Here you are given that the paged memory is given where the page hit ratio is 0.4. So here, first info that we have got is hit ratio is given as 0.40. If hit ratio is given, that means let me call this as H. So miss ratio kitni hogi? Total ratio 1 है, so definitely miss ratio will be 1 minus H. So that is nothing but 1 minus 0.40, which comes out to be 0.60. This is the miss ratio. अगर hit हुआ है, hit हुआ means you are getting the page from the main memory. Miss means the required page is not available in the main memory. So उस case में page को कहाँ से access करेंगे? From the secondary memory. So the time required to access a page in the secondary memory is equal to 120 nanoseconds. So secondary memory access time, let me call this as y, and main memory access time को मैं x बोल रही हूँ. Main memory access time is, let's say, x. So main memory access time is given as 15 nanoseconds and secondary memory access time is given as 120 nanoseconds. We want to calculate the average access time. So the concept is very simple. 60 or 0.60. 0.60 is not in the options. 60 is not in the options. Oh, you are returning the miss ratio. Yeah, so miss ratio is 0.60 undoubtedly. So now can you tell me that what will be the average access time required to access a particular page? So we are supposed to calculate the average time required to access a page. So what will be that? सबसे पहले हम क्या करेंगे? We will look into the main memory whether the page is available or not. So if the page is available in the main memory, that is the hit ratio. अगर page available है main memory में, then we will access the main memory. So access time of main memory. अगर पेज मेन मेमोरी में अवेलेबल नहीं है यानी कि मिस हुआ है, सो देयर इज अ मिस रेशियो 1 माइनस एच. अगर मेन मेमोरी में पेज नहीं मिला तो डेफिनेटली विल बी गेटिंग दैट पेज फ्रॉम द सेकेंडरी मेमोरी. सो वी नीड टू कंसिडर द एक्सेस टाइम ऑफ secondary memory. Now just substitute the values. All the values are given to you. Hit ratio is given as 0.40. Access time of main memory is given as 15 nanoseconds. Miss ratio is 0.60 and access time of secondary memory is 120 nanoseconds. So this comes out to be 0.40 into 15 is 6 plus this is 72. Everything is in nanoseconds, so average access time will be in nanoseconds. So we are getting this as 78 nanoseconds. That is nothing but, again, it is option 4. Simple. So if you know how you are going to access the memory, किस तरीके से access जाता है, तो easily आप ये formula लिख सकते थे और सारी की सारी values आपको question में given थी, you just had to substitute the values. In fact कोई conversion भी नहीं है, इसी question को अगर complex करना होगा तो यहाँ पे units में change कर दिया जाएगा और options देखकर, although here it is not mentioned, otherwise आप options देखकर identify करते हो कि जो answer चाहिए वो कौन सी units में चाहिए. So yes, Shubham, you have returned the correct expression, but you were supposed to simplify it. Very good, Hemant and Arun, you got the answer right. So although they didn't ask for the units, but whatever calculations you have done, जो भी time दिए गए हैं, वो सब nanosecond में दिया गया है. So that's why it is 78 nanoseconds. Arijit, we will be discussing the schedule. Let's finish the questions first, and after that, whatever queries you have related to the schedule, I'll discuss that. Okay. Effective average access time or the average access time, is this the same? Yes, that is the same. All right. Shall I move to the next question? Next one. Now this is again based on the cache memory. So we have talked about mapping techniques. We discussed the mapping techniques. Here they are saying that we have a direct mapped cache and you have to return the number of bits that will be used for the tag, used for the line, and used for the word offset field. So we know that the format is, we have three fields here: tag, line. Line number is basically representing that how many cache lines are there, and here we have the word offset. This is word offset. So if you are given with the block size will tell you how many bits will be used for the word offset. So word offset kaise calculate karte? That is nothing but, because everything should be in bits, so we will be taking a log of what? Block size. So if you see this, in this question, the block size is given as 8 bytes. So in order to represent 8 bytes, how many bits are required? 8 bytes को represent करने के लिए कितनी bits चाहिए? We are given that the main memory is byte addressable, and main memory this contains 2 raised to power 16 bytes. And block size is given as 8 bytes. So if the main memory is taking 16 bytes, that means पूरी memory को represent करने के लिए 16 bits are required. 2 raised to power 16 है, तो how many bits are required? Obviously this is 16 bits. Now these 16 bits are divided into 3 parts: tag bits, line bits, and the word offset bits. Block size is given as 8 bytes. That is nothing but 2 raised to power 3 bytes. So what will be the word offset bits? 8 combinations. In order to represent 8 combinations, 3 bits are required, log base 2 raised to power 3, which comes out to be 3 bits. So 3 bits are taken by the word offset. So on the basis of this, we can eliminate option 2 and 3. Now, assume that the direct mapped cache consisting of 32 lines. That means cache के अंदर कितनी lines आ रही है? Number of lines in the cache, number of lines in cache memory, that is given in the question, that which is equal to 32. 32 is nothing but 2 raised to power 5. So in order to represent 2 raised to power 5 combinations, आपके पास total कितनी lines है? 2 raised to power 5. एक line को represent करने के लिए कितनी bits चाहिए? Again, we'll be taking the log here. Log of number of lines. Number of lines are given in the question. So this comes out to be log base 2 raised to power 5, which is coming out to be 5 bits. So 5 bits are used as the line bits. 5. Total bits आपके पास 16 है. 16 में से 5 plus 3 is 8. So remaining bits will be used by the tag. So it comes out to be 8. How I am getting the tag bits? Total number of bits 16 minus line offset, line bits. This is 5 minus 3. That comes out to be 8 bits. Correct. So correct answer for this question is 853. That is option 1. So 16 is representing the total bits minus line bits minus offset bits. All right. So this is 853. Easy, simple. Memory के questions easy लग रहे हैं. Next one. We have talked about 3 types of mapping techniques, right? Cache memory में हमारे पास 3 तरीके की mapping techniques होती हैं. Here they are asking that which of the following mapping is not used for mapping process in cache memory. इनमें से जो भी आपको ये मैपिंग टेक्निक्स दी हैं, इनमें से कौन सी मैपिंग टेक्निक है जो कैशे मेमोरी में नहीं आती? Is it associative mapping? Is it direct mapping? Is it set associative mapping or segmented page mapping? What is that? What is that? Very good. Segmented page mapping is not used. Segmented page mapping हम किस में use करते हैं? Main memory. Segmentation. But in cache memory, we do not have segmented page mapping. Associative mapping, direct mapping, and set associative mapping. These are the 3 mapping techniques which we use for cache memory. Next one. This is based on the disk. Question concern a disk with the sector size 2000 tracks per surface, 50 sectors per track, 5 double-sided platters are there. Every seek time is 10 milliseconds and rotation delay is given as 5400 rotations per minute. Then approximately what is the maximum rotation delay? Maximum rotation delay means एक rotation के लिए how much time is required. So this whole information is not required. यहाँ पे आपको बताया गया है कि disk platter किस speed से rotate हो रहे. This is 5400 rotations per minute. RPM means rotations per minute or revolutions per minute. So this means that in 1 minute, or we can say that 5400 rotations कितने टाइम में हो रही है? 1 मिनट में. और in 1 minute, okay, 5400 rotations in 1 minute. हमें क्या फाइंड करना है? We want to calculate कि कितना टाइम लगेगा मैक्सिमम एक रोटेशन के लिए. So that will be 1 rotation requires simple calculation है 1 divided by 5400 minute. But answer is asked in the form of the seconds. तो इसको minute को हम किस में convert कर देंगे? I'll be converting this to seconds. Question खत्म. Calculated. It comes out to be 0.011 seconds. So correct option for this question is it's option 1. That is 0.011 seconds. Simple. Let's discuss few more questions on the basis of the disk. Same data hai, everything is same. Now in this case, we are supposed to find out 1 track of data can be transferred per revolution. Obviously बात है जब एक rotation होगा तो एक track का data transfer होगा. Then what is the data transfer rate? What will be the data transfer rate? So for this, we need to calculate how much data is there in 1 track. So what is the data? for one track, data stored on one track, or you can also call this as track capacity. What is the track capacity? एक track को हम sectors में divide कर रहे हैं. So here number of sectors are given as number of sectors are 50, and you are given with the sector size. Sector size is given as 512. So this comes out to be number of sectors into sector size. Substitute the value. Number of sectors are 50 and sector size is 512 bytes. So this comes out to be approximately 2500 bytes or 2500 bytes. Or do the proper calculation. Approximately ले रही हूँ, so it is 25 because जो options आ रही हैं there is lot of variation, तो आपको calculation पे time waste करने की जरूरत नहीं है. Approximately 2500 bytes. Now this is saying that 2000 tracks per surface, but we have to find out the transfer rate, यानी कि per second how much data will be transmitted. So what will be the data transmitted per second? You just need to divide this value. So it is divided by per second. We have already calculated for one rotation, this is taking 0.011 second. So when you'll be dividing this value, it comes out to be, so here data transfer rate. What will be the data transfer rate? Approximated find kar lo. So this is whatever data is there, data divided by, why it is giving us K. Okay. So this is the capacity of the track. If you calculate the total data will be nothing but that is number of tracks into number of sectors into sector size, right? So that will be the giving you the total data. Anyhow, the data transfer rate is coming out to be approximately whatever is the data transferred per second. So it is approximately 2250 because no other option is close to this. So it is 2250. Next, given below are two statements. The disk has a total number of, some data is I guess missing for this question. The disk has a total number of 2000 cylinders. Okay, this question is also related to this question. So in this case, you can see that 2000 tracks are given. Tracks kya hote hain? These are nothing but the cylinders. So we can say that this is saying that the total number of cylinders are 2000. So these are nothing but 2000 tracks only. So this statement is correct. Cylinders are the tracks only. So statement 1 is true. Statement 2, 51200 bytes is not a valid block size for the disk. इस स्टेटमेंट के पीछे क्या लॉजिक हम यूज करते हैं? जो भी आपके पास डेटा ट्रांसफर होता है दैट इज ऑलवेज इन टर्म्स ऑफ, दैट इज ऑलवेज अ मल्टीपल ऑफ सेक्टर साइज. मोरओवर जितना डेटा ट्रांसफर होगा दैट इज nothing but block size is dependent on block size cannot be greater than the track size. Block size cannot be greater than track size. अब जो हमने track size calculate किया था, track size is nothing but track size, or you can say track capacity, that is number of sectors. ट्रैक के ऊपर सेक्टर्स और सेक्टर्स के अंदर डेटा है, सो नंबर ऑफ सेक्टर्स इनटू सेक्टर साइज. Number of sectors are given as 50. I'm referring to this data only. So number of sectors are 50 and the sector size is given as 512 bytes. 50 into 512 bytes. So this is close to 25000. I'm writing here 25 and 3 zeros, so approximately 25 zeros. So this is 25, approximately 25000. इसके आसपास आएगा. So if you see here, it is saying that it is going to transfer 512 bytes, or you can say that 51,200 bytes, but कि एक ट्रैक का जो साइज है, ट्रैक कैपेसिटी है, that is approximately 25,000. So this is going to exceed, your track size is going to exceed the number of bytes that it is transferring. So definitely this is not the valid bytes of data that can be transferred in one block. So statement, और यहाँ पे option में आपको दिया हुआ है, this is not a valid block size. So yes, this statement is also true. Reason is written over here. So this means that both statement 1 and statement 2 are true. So ये जो हमने questions किए हैं, last 3 questions, these questions are linked. Okay, so you can relate to these questions. Anyone having any doubt? One more question on the basis of the track. Here it is saying that the number of bits required to specify the particular sector. अगर किसी particular sector पे जाने तो सबसे पहले हम क्या करेंगे कि we need to identify if multiple surfaces are there. अगर मल्टीपल डिस्क हैं तो पहले हमें ये आइडेंटिफाई करना पड़ेगा कि डेटा कौन सी डिस्क पे स्टोर्ड है. डेटा इज स्टोर्ड ऑन विच डिस्क. Okay, these are the cylinders. Make sense? So first of all, we need to identify how many disks are there. This is saying that consider a disk pack with 32 surfaces, 64 number of surfaces are given as 32. Then number of tracks are given as, Arijit, I'm coming to your doubt. Just give me 2 more minutes. I'm going to finish these questions. Number of tracks is equal to 64 and एक track के ऊपर कितने sectors हैं? Number of sectors is equal to 512. हमें कहाँ तक आइडेंटिफाई करना है? वी नीड टू आइडेंटिफाई द पर्टिकुलर सेक्टर. हमने ये बोला है कि हमें नंबर ऑफ बिट्स चाहिए जो किसी पर्टिकुलर सेक्टर को आइडेंटिफाई करेंगी. तो किस तरीके से प्रोसीड करते हैं? फर्स्ट ऑफ ऑल वी नीड टू आइडेंटिफाई कि कौन सी सरफेस पे, वेदर इट्स ऑन सरफेस 1, सरफेस 2, सरफेस 3. तो सबसे पहली सिलेक्शन होगी सरफेस के ऊपर. आपके पास 32 सरफेसेस हैं. दिस मींस दैट दिस विल बी टेकिंग 5 बिट्स. सरफेस को आइडेंटिफाई करने के लिए 5 बिट्स आर रिक्वायर्ड. 5 bits to select the surface. After that, जब surface select हो गया, for example, this surface is selected. Now on this surface, lot many tracks are there. कितने tracks हैं? This is given as 64. Now I need to identify that which track is being used. So in order to identify the track, 6 bits are required. ट्रैक सेलेक्ट हो गया. अब एक ट्रैक के ऊपर मल्टीपल सेक्टर्स आर देयर, नाउ वी नीड टू आइडेंटिफाई कि हमें कौन सा सेक्टर चाहिए. सो 512 sectors means 2 raised to power 9 sectors are there. In order to uniquely identify each sector, 9 bits are required. तो सेक्टर तक पहुंचने के लिए कितनी बिट्स चाहिए? फर्स्ट ऑफ ऑल 5 bits for selecting the surface, then 6 bits for selecting the track, then 9 bits for selecting the sector. So this comes out to be 11 plus 9 is 20, so 20 bits are required. Correct answer for this question is 20 bits. So if you have understood the structure of this disk structure is clear, then easily you can handle these type of questions. आपसे या तो rotation latency पूछी जाएगी, seek time पूछा जा सकता है, seek time given होगा, capacity पूछी जा सकती है, कितना data transfer होगा, what is the data transfer rate. These are the different types of questions that can be asked from the topic disk structure. In this case, I want to return the capacity of the disk. Disk की capacity कितनी होगी? So it depends on what? It is saying that we are having how many surfaces are there? First of all, you are given with the sector size. This is the last question from today's session. Quickly solve it. Sector size is given as 512 bytes. Number of tracks per surface. Number of tracks are given as 2000. Then 50 sectors per track. Number of sectors per track are 50, but जो हम calculation start करते हैं, we need to identify कि surface कितनी है. So 5 double-sided platters are there. That means number of discs, number of platters 5 है, यानी कि 5 डिस्क है और दोनों साइड पे डेटा रिटर्न हो सकता है. So number of surfaces जिसके ऊपर आप डेटा लिख रहे हो, what will be that? 5 डिस्क है और दोनों साइड पे काम कर रहे हैं. 5 into 2, that is 10. Now we are supposed to return the capacity of the disk. So capacity of disk is nothing but capacity of disk. सबसे पहले हम क्या फाइंड करते हैं? नंबर ऑफ सरफेसेस डायरेक्टली लिख लो या फिर नंबर ऑफ प्लैटर्स. कितनी सरफेसेस पे डेटा लिख रहे हैं? दोनों साइड पे या एक साइड पे? नंबर ऑफ surface, or you can say that number of, okay, let me write this as surface, total number of surfaces into आपको total number of surfaces मिल गई. अब हर surface के ऊपर tracks है, number of tracks. Each track is divided into number of sectors, and ultimately in the sector we are storing the data, so that is the sector size. See what all values are given to you. Number of platters are 5. Number of surfaces दोनों side पे लिख रहे हैं, both side. Number of tracks are 2000, and on each track number of sectors are 50 and sector size is 512. Correct? Is this clear? So this comes out to be, just simplify it, this comes out to be k, यानी कि 3 bits यहाँ पे चलेगी. So let's remove it for k. 5 into 2, 10. 10 into 10 is again coming out to be 100, 1000, and let's consider this as 50. So this comes out to be 50. One, 2, 3, and 4. 4 zeros, and remaining calculation is 500. So count the number of zeros. So this is coming out to be 500,000. So this is all about this session, so we'll end our discussion here. Anyone having any doubt? Anyone having any doubt? So if you are comfortable with this formula, definitely you'll get the right answer. So 50,000 BA, 500,000 BA. So correct answer for this question is it's option 2. So this is all about this session. Next session may I'll be taking all the questions from the memory, cache memory or registers. Now let's discuss the doubt. So currently what all live sessions are going on. So for paper 2, दो लाइव सेशंस चल रहे हैं. अगर आप पेपर 2 की बात कर रहे हो, देन वी हैव वन सेशन इन द मॉर्निंग. मैं हर सेशन में बताती हूँ, आई डोंट नो व्हाई दिस कंफ्यूजन इज कमिंग अप अगेन एंड अगेन. मॉर्निंग में सेशन टाइम इज 7:30 AM to 9:30 AM, and in the evening it's 8 PM to 10 PM. In the evening, we have started with operating systems. So today we will be talking about CPU scheduling algorithms. Morning में today we are going to start with the tomorrow will be the first session. So we'll be having the first session on computer graphics. Okay. And for the evening, Monday and Tuesday is off. And here Thursday is off. एक तो ये सेशंस चल रहे हैं, मैं सिर्फ और सिर्फ लाइव सेशंस का स्केड्यूल बता रही हूँ. एंड अपार्ट फ्रॉम दिस आई एम टेकिंग द लाइव सेशन ऑन द यूट्यूब जो डेली होता है at 6:30. Apart from this, I'm going to start with the master classes. Master classes का टाइम आपको अपडेट कर दिया जाएगा. Master classes. दिस इज अबाउट, ये सारी की सारी इंफॉर्मेशन पेपर 2 की है. पेपर 1 की जो लाइव क्लासेस हैं वो दोपहर को होती हैं 12:30 बजे, 12:30 PM, 6 days a week. So here only Sunday is off. Obviously for paper 2 there is no Saturday or Sunday off. जो ऑफ है that is in the weekdays. इसके अलावा आपका क्या डाउट है अरजीत? आई हैव टू डाउट. टेक्स्ट बुक एक्ट पर भी मैम ये ऐसे एमसीक्यूज वाली क्लास होती है क्या? अभी डेडिकेटेडली सिर्फ एमसीक्यूज की क्लास नहीं हो रही है. दैट विल बी स्टार्टिंग दैट इन द मास्टर क्लासेस. ओके, टाइमिंग बता दीजिए उसका. एंड सेकेंड डाउट इज दीज क्वेश्चंस आर यूनिट 2 नॉट डिस्क एंड मेमोरी क्वेश्चंस. तो मैं यूनिट 2 और यूनिट 5 में से क्वेश्चंस ले रही हूँ. तो कुछ कुछ क्वेश्चंस मेन मेमोरी के भी आ रहे हैं इसमें. एंड वी आर कवरिंग द कॉन्सेप्ट्स ऑफ कैशे मेमोरी एज वेल. डिस्क स्ट्रक्चर ऑब्वियसली हमारे पास ऑपरेटिंग सिस्टम में कवर करेंगे. वी हैव स्टार्टेड विद दैट बट वी हैवंट कवर्ड दैट. ओके, क्योंकि जो YouTube है दैट इज द ओपन प्लेटफॉर्म, सो दैट इज फॉर एवरीवन. So that is why I'm taking the questions from the disk as well. But I know that there are many students, those who are not comfortable with the concept of disk. So what I can do is I can plan one dedicated session on the disk structure, and after that we'll be taking its questions. Master class में क्या होता है? Master class is on the Testbook platform. Master class Testbook platform पे होगी और उसमें हम सिर्फ और सिर्फ questions करेंगे. So what I'm thinking is on the YouTube, let me discuss only the important concepts. Okay. And जितने भी questions हैं, previous year questions है, questions practice questions की series है, जो भी practice sessions या questions से related series है, we will be conducting that in the master classes. ओके, सो यूट्यूब पे अभी इस वीक के लिए हम लोग जो अभी चल रहा है इन क्वेश्चंस को खत्म करते हैं. एंड आफ्टर दैट ऑन द यूट्यूब आई विल बी कवरिंग द इम्पोर्टेंट कॉन्सेप्ट्स. अगर आपको किसी भी कॉन्सेप्ट में डाउट है और यू वांट मी टू टेक द सेशन ऑन दैट कॉन्सेप्ट, प्लीज लेट मी नो. आई विल डेफिनेटली कंसिडर योर रिक्वेस्ट. we will be covering important concepts on YouTube, practice questions on masterclass, और paper 2 detailed syllabus cover करना है आपको live sessions में. For that you can follow the super coaching schedule. This is the schedule for the super coaching. If you want to get to know more about super coaching and you want to cover your whole syllabus in the live classes, paper 1 और paper 2 दोनों का पूरा syllabus आपको live classes में करना है, तो उसके लिए आप super coaching join कर सकते हैं. Currently the sale is going on, and if you want to get to know more about the super coaching batch, then the link is given in the description box. उसके अलावा टेलीग्राम ग्रुप का लिंक दिया गया है, आप अपनी क्वेरी उसमें भी पोस्ट कर सकते हो. अगर आपकी कोई रिक्वेस्ट है कि इस पर्टिकुलर टॉपिक पे सेशन ले लो, वो भी आप टेलीग्राम ग्रुप में डाल दो. डेफिनेटली आई विल रिस्पॉन्ड टू इट and I'll consider your request. Okay. I hope that there are no pending queries. So this is all from my side. Apart from that, if you have any other doubts, you can ask. 12:30 वाली क्लास में भी MCQs हो रहे हैं. Maybe since जो 12:30 बजे क्लास हो रही है वो पेपर 1 की क्लास हो रही है, so I do not know what is the structure जो अभी इस टाइम पे पेपर 1 में फॉलो हो रहा है. तो पेपर 1 से रिलेटेड क्या सिलेबस चल रहा है वो मैं नहीं बता पाऊंगी. पेपर 2 में मॉर्निंग और इवनिंग में क्या चल रहा है, यूट्यूब पे क्या चलेगा, मास्टर क्लास पे क्या चलेगा, वो मैं आपको बता सकती हूँ. ओके. एंड डेफिनेटली इफ यू आर लाइकिंग दीज सेशंस, आपको इंफॉर्मेशन यूजफुल लगती है, आप रेगुलरली फॉलो करना चाहते हो, देन डोंट फॉरगेट टू सब्सक्राइब द चैनल एंड लाइक द वीडियो ऑब्वियसली. एंड अगर आप चाहते हो आपको नोटिफिकेशंस मिले तो बेटा बेल आइकन को भी क्लिक कर दो. यू विल स्टार्ट गेटिंग द notifications. And those who are interested in getting the super coaching, in order to get the discount, definitely आपको coupon code चाहिए, so you can use the coupon as Shefali S. Okay, this is the code that you can use to avail the discount. I cannot see any more queries, so we'll end our discussion here. Thank you so much guys for joining the session. I'll see you in the next session. Till then, take care. Bye bye.